Hi. Okay, so we're looking at polluting the atmosphere today. This is the last part of this very brief topic on the atmosphere. We talked about the history of the atmosphere. We talked about what's happening with global warming and climate change, and now we're talking about how we are damaging it in ways that are not good. So we've talked about unbalancing it with the greenhouse effect, but there are other chemicals that we are putting into the atmosphere. I'm going to tell you about those today. But let's just start off. What has happened to the amount of CO2 in the atmosphere? How much is there currently? Where do they measure this? And what is the greenhouse effect? Pause the video, answer the questions, and when you're done, we'll go through the answers together. So what is happening to the amount of CO2 in the atmosphere? It is increasing. How much is there currently? I think during lockdown, it was recorded as about 415 parts per million, which is quite a scarily large amount. Where do they measure this? They measure this on the top of a mountain in Hawaii. And what is a greenhouse effect? It is the warming of the planet due to the blanket, of gases. There we go. So, not my finest handwriting, but hopefully that's enough to remind us what we need to know to keep going. So, let's go. So, today, these are the things we're going to learn about. We're going to learn about carbon dioxide, nitric oxides, carbon monoxide, sulfur dioxide, and particulates. So, the first thing you need to do is pause this video, copy this down into your book. Take the full width of the page. This is pretty much the only thing you're going to write in terms of making notes, apart from filling it in. So, use most of a page for this. Pause and unpause once you're done. Done? Let us begin. The most common pollutants found in air are carbon dioxide, sulfur dioxide, carbon particulates, nitrogen monoxide, carbon monoxide, and nitrogen dioxide. How are these molecules produced? And how do they affect the environment? So in the table, let's go back, you're going to have to know the first column is going to be how do they get there? How do we produce them in the atmosphere? And the second one is what do they do to us? Let's go there. Boop. And for those of you who are unaware, the ones in yellow are acidic. So let's go through one by one. Carbon dioxide. Carbon dioxide, what is the cause? It comes from burning fossil fuels. You know about that. We mentioned that last time. Burning coal, oil, and gas. These things trapped coal and carbon into the Earth's crust, into the Earth many years ago. And then by burning them, we release them. So carbon dioxide is a greenhouse gas. It traps infrared radiation, heat, in the atmosphere, and it raises the Earth's temperature. Increasing emissions are thought to be related to climate change. There's no thought. It is. So you can do the first box. Or look, there are other examples we can add later. Carbon monoxide. Now, carbon monoxide is pretty unpleasant. And hopefully in your house, if you have a gas boiler and you have hot water that comes from gas, you should have next to it a carbon monoxide alarm. If you don't, please go and ask your parents to get one. It could be the matter of life and death. The cause of carbon monoxide is incomplete combustion of fossil fuels. This can happen in a faulty gas appliance and road traffic. If something goes wrong and something stops the air intake for your boiler, it will produce carbon monoxide. The effect carbon monoxide is very dangerous. It decreases the ability of blood to carry oxygen, and if untreated, it can lead to death. Carbon monoxide has no smell, so if it's building up in your house, you wouldn't know. You would just get sleepy, and then, unfortunately, you wouldn't wake up. So having a carbon monoxide alarm is very, very, very important. Sulfur dioxide. If you use a power station, you don't use a power station. If power stations burn fossil fuels, they know that they do. Inside the fossil fuels, there are impurities called sulfur. When you burn them, the sulfur in the fossil fuels combines with oxygen in the air, making sulfur dioxide. And sulfur dioxide is an acidic gas. Ugh. When it combines with water vapor in the atmosphere, basically clouds, it causes acid rain. Breathing in sulfur dioxide also causes respiratory problems. Breathing in an acidic gas is bad. Acid rain is bad. Particulates, airborne particulates. They're another thing of when fossil fuels burn with less oxygen, not enough oxygen. Fine particulates can get into the lungs, causing breathing difficulties. And particulates deposits on cars and buildings make them look dirty. So if things get covered in soot and dirt and whatever, those are particulates. They're easier to see than carbon monoxide. Carbon monoxide is clear and odorless. Particulates are dirty and you can see them. So in some senses, they're perhaps less dangerous because they're not as sneaky as the carbon monoxide. And nitric oxides. Road traffic and power plants, high temperature combustion enables reactions between nitrogen and oxygen. Lightning also forms nitric oxides. Nitric oxides can combine with water vapor to cause acid rain. They can also cause smog. So those are some important air pollutants. So let's just review. Combustion. Fuel plus oxygen makes carbon dioxide and water. That's always confused me. Burning makes water, which is kind of crazy in the scheme of things. But if you burn a fossil fuel, which has a large amount of carbon in, oxygen in the air makes carbon dioxide and water. Fossil fuels have carbon and hydrogen. They are called hydrocarbons. But if you burn them, the carbon mixes with the oxygen to make carbon dioxide, and the hydrogen mixes with oxygen to make water. Obviously, we talked about issues. Problems with burning fossil fuels include increased carbon dioxide levels due to human activities. These are causing global warming. Obviously, combustion produces carbon, particulate matter, and they often contain sulfur dioxide. Carbon monoxide, I mentioned this before. Carbon monoxide is incredibly harmful to human health. It stops the blood carrying oxygen. Faulty gas appliances such as heating boilers can produce carbon monoxide. The gas is colourless and odourless, so they need to be checked for safety at least once a year. In fact, this used to be an issue many years ago, a lot more than it is nowadays, and as a consequence, there are very big laws resulting in where you can have a boiler in your house and the ventilation. If a gas engineer comes to your house and sees something wrong, what they'll do is they'll condemn your boiler immediately and they'll just turn it off because it's such a high risk. If you have a chimney in your house, also, those things can have the same. If you have chimney and you'll have a fire in there and there's not enough oxygen gets in, you can make carbon dioxide the same way. There have been instances when people, when they've done camping and they've used a little gas burner or something inside their tent, or if you have a barbecue just outside the door of your kind of opening to your tent, so not even in your tent, what happens is the barbecue or the gas fire burns, but because it's close to the tent, it means there's not enough oxygen getting to the fire and it produces carbon dioxide, and that can fill the tent with carbon monoxide, causing you to die. So it's really important when you have a fire. Obviously, you need to have a fire in controlled conditions, but making sure it gets lots of air to it. One, it makes the fire burn better, but two, it makes the chance of it producing carbon monoxide much less. Carbon monoxide is very, very bad. Burning wood can also produce carbon monoxide. In areas where forests have been cleared and burned, carbon monoxide levels can reach dangerously high levels. That's just making sure it burns with enough oxygen. Acid rain or precipitation with a pH of 5.6 or lower is caused by the pollutants sulfur dioxide and nitric oxides. Acid rain causes millions of pounds worth of damage to buildings in the UK every year. If a building is made from something that reacts with acid, limestone, calcium carbonate, it will literally just dissolve in the rain, and it causes buildings to dissolve, particularly older buildings rather than newer buildings. Also, if it gets into lakes, it can poison fish. If it goes into the ground, if taken up by plants, it can cause damage to crops and other land. Acid falling from the sky, never really a good thing. What is acid rain? Let's have a look at the animation. Gases, sulfur dioxide and nitric oxide, are produced during combustion. Traffic, factories and power plants are the source of these pollutants. The sulfur dioxide and the nitric oxides react with water vapor held in clouds. So the gases go up, they join with the clouds, they form acid rain. Normal acid rain is slightly acidic, less than 5.6 pH. And then the rain comes. The rain causes millions of pounds of damages to buildings in the UK every year. Also, limestone, marble and sandstone are especially vulnerable. Rain just dissolving your house. Truly a terrifying prospect, particularly in a country like this where there is a lot of rain. It also can go into rivers and lakes and the sea, killing small things and fish and other things. It also damages trees. So the things that can clean the air get killed by acid rain. Aren't we good? Acid rain is an international problem. It can fall hundreds of miles away from the source of the pollution. Pollution created by one country can damage another. So the things that you're doing can cause damage somewhere else, or the things that some other people are doing can cause damage to you. It's an international problem with international solutions. Not burning fossil fuels is the main solution. Okay, so at the start you wrote down this table. Let's see how you should have filled it in. Carbon dioxide, how is it caused? It's caused by combustion and respiration. What is an issue? The effect is it adds to the greenhouse effect. Nitric oxides, they occur when there is high temperature combustion. The effect can cause acid rain and smog. Carbon monoxide occurs when there is incomplete combustion, when there's not enough oxygen for the burning. And the effect, it lowers the blood's ability to carry oxygen, or death. Sulfur dioxide is when you burn coal or other fossil fuels. Effect is acid rain. And particulates, again, it's when you burn wood and other fossil fuels, often when there's also not enough oxygen. More oxygen means less particulates. And the effect, it leaves dirty deposits everywhere, and it can damage your lungs if you breathe it in. We're nearly at the end. I'm going to upload this quiz to this PowerPoint to the VLE, so you can do this one yourself. So just click, it's multiple choice. It's good to test your knowledge. And here we have. So what I'm doing is I'm going to go through this, and then a chance for you to do it yourself. What are the missing words about air pollution? The something of fossil fuels is a major source of air pollution. Is it combustion or respiration? Combustion. One effect of air pollution is acid rain. This is formed when sulfur dioxide and nitric oxides combine with water vapor. Nitric oxides are formed when oxygen and nitrogen react under high temperatures found in combustion engines. Burning coal that contains sulfur produces sulfur dioxide. Carbon monoxide is formed by the incomplete combustion of fossil fuels and can reduce the ability to carry oxygen. Common particulate is carbon, and particulates can damage the lungs. Check that. Oh, got it all right. Well done, us. Now, were you paying attention? What you need to do is write the numbers 1, 2, 2A, 2B, 3, 4, 5, 6A, 6B. And then just write down what were the words for each of those things. Can you fill in the missing words for that thing? It says start for next lesson. That is a lie. That's now. So copy down the numbers. Don't copy the whole thing out, and write down the words. And the last activity for today. Imogen is calculating her carbon footprint using a website she has found on the internet. Where else would she find the website? Her results so far are shown below. She took a return flight to Barcelona. It released 0.2 tons of CO2 per year. The 5,000 miles on a moped, 0.82 tons of CO2, and travel to school on a school bus, 0.33 tons of CO2 released per year. Part A, complete the table by calculating Imogen's total carbon footprint. Can you suggest 2 other activities that Imogen is likely to carry out that she has not included in her calculations? Just normal human things that you might do. A tree can absorb as much as 0.02 tons of carbon dioxide every year through photosynthesis. Can you write the word equation for photosynthesis? And then calculate the minimum number of trees Imogen must plant to offset the carbon emissions from her journey to the school on the school bus. That's it. You've done it all. Well done. So answer the questions, take photos of your work, send it to your teacher. If you're not sure, ask questions. Good luck. Love you. Bye.